This online pendulum simulation is to be used with the data collection and processing pendulum activity that is found on the student Google site Pendulum page. The purpose of this data collection and processing activity is to use this simulation to look at the relationship between the length of a pendulum and the period of its swing. In a second process, we're then going to use the relationship between the length and the period to calculate the value of gravity on Earth. Instructions on the second process can be found on the data collection and processing instruction sheet that is attached to the Pendulum page. However, to manipulate this simulation, we're going to need to use the sliders and controls that can be found to the right of the simulation itself. The first slider we find is the length. Length in this data collection and processing activity is the independent variable. That is, that it's the variable we have control over. And if we vary the length, you can see that the length of the pendulum in the center of the screen either increases or decreases. We can also increase and decrease the mass of the bob. And if we decrease the mass of the bob, you can see it gets smaller. And if we increase it, you can see it gets bigger. However, for this activity, we're going to keep mass constant, and we're going to set it at 1 kilogram and not touch it for the remainder of the data collection and processing activity. If your teacher wishes, after you've completed this activity, you can always come back and look at the relationship between mass and period. However, for this activity, mass is going to remain constant. Other things that we have control over. We could include a second pendulum. We're not going to. We're going to keep this nice and simple, and we're going to just have one pendulum at all time. We can also change the timing of the pendulum, and we can change the gravitational field with which the pendulum swings within. We're going to keep the pendulum at real time because we can easily measure it in real time, and we're going to leave the gravitational field as Earth because in the second process we're going to use the relationships that we find from this pendulum to try and calculate the value of gravity on Earth, which we know is about 10 meters per second squared. Other things that we can show on this pendulum are velocity and acceleration relationships and energy relationships. However, for this activity or for this data collection and processing activity, none of these are going to be needed. What we are going to require is the photo gate timer. And if we click this, you'll see that the photo gate timer is shown to the left of the screen. The other tools icon we don't require, and we also don't need this ruler here, which is to the left. You can use it to measure if you want to, but to be honest, you can see that the length slider comes with a numerical value, and we can quote that numerical value with suitable error throughout the investigation. So we're going to set the slider at 2.50 meters, and we're going to move the pendulum to a release angle of 30 degrees. 30 degrees is going to be the release angle at all times throughout this investigation. We're not going to change it, and for all lengths of pendulums, we're going to keep it at 30 degrees. Again, you could come back after completing this DCP activity and look at what happens when you change the release angle, but for this investigation, we're going to maintain it always at 30 degrees. The last thing we have control over is friction. Now, we can increase the friction, or we can increase the friction, have lots of friction like what we have in the real world, or we can have no friction at all. For the purpose of this activity, we're going to keep friction to be none. By having no friction, you can see that the pendulum always returns back to its original starting point of 30 degrees, be it to the left or to the right. So in a sense, no energy is being taken away from the pendulum, and the pendulum will swing at this, the pendulum will constantly return to this release angle for all time until we press the reset button down in the bottom of the screen. The only thing we have to do now is to measure the period of the pendulum, and we're going to do this using the photo gate timer in the bottom left hand side of the screen. If I click start, you'll notice that the timer starts from the equilibrium position and then ends when it recrosses the equilibrium position from its starting position. And you can see that for a length of 2.50 meters, we have a period of 3.2269 seconds. If I reset the pendulum and I re-release the pendulum at 30 degrees, you can see the photo gate time has gone back to 0, I can press start whenever I want, so I'm going to do that here. Again, you see it only starts when it crosses the equilibrium position, and I've got 3.2269 seconds again. If I reset the pendulum, the period goes to 0, and then I'm going to change my length of my pendulum to 2.30 meters, and I'm going to do the same thing again. 30 degrees, let it go, start, crosses the equilibrium position, and then when it crosses it again, you'll see that we end up with a period of 3.0951 seconds. Pretty straightforward. All you're going to do for this investigation is change the length of the pendulum, decreasing at 0.20 of a meter each time until we eventually get down to 0.50 meters. All you need to do now is go back to the DCP pendulum page that's on the Google site, read the pendulum DCP instructions page where this procedure is re-explained, process 1, which is collecting the data, is explained, and process 2, where manipulating the data to measure the value of gravity on Earth, is found. Thank you very much.